Hello, it is Thursday, May 21st, and on today's edition of Kitchen Table Chemistry, we are going to try to draw covalent structures. That will be our function. So today's topics are threefold. Number one, multiple bonding. Number two, sigma and pi bonding. And number three, the Lewis structure rules. All right, let's get in. The first two are kind of related to each other, and then the third one I'm going to show you. Okay, formation of bonds. A sigma bond is a structural bond. So if X is bonded to Y, that line here, that single bond is called a sigma bond. So a sigma bond, and it's easy to remember because it is a single bond. So single, sigma, and single bond. That, if that's all that's needed to satisfy the octet, that'll be great, and that's what we do. Pi bonds here are multiple bonds. And this is when we need to do something different to satisfy the octet. So let's take a look at O2, which is the oxygen that we breathe. Each oxygen has 6 valence electrons like this. And if we just make a single bond by circling these two, which would be a sigma bond, that's not going to satisfy the octet. So we're going to make a second bond, and this bond is going to be called a pi bond. So the first bond is a sigma bond. The second, if we have to make them, are called pi bonds. So the pi thing in there, okay? All right, now, how do atoms form multiple bonds? And that they are going to share multiple electrons here. Now let me show you this. Two nonmetals share 2 pairs of electrons. So this will be 4 valence electrons. And I just showed you oxygen. But let's take a look at another thing here, carbon dioxide. Okay, I'm going to put carbon in the middle. And the reason carbon's going to go in the middle is it has the most bonding electrons and the lowest electronegativity. When we're making structures, the thing that you want to start putting in the middle is the thing with the most bonding electrons and the lowest electronegativity, the lowest EN. So I'm going to put an oxygen on this side with its 6 valence electrons, and oxygen on this side with its 6 valence electrons. Now, notice that I've drawn carbon like this with 1 electron on each side. Always draw your carbons like this. Carbon promotes an electron and comes up with this very, very stable structure where it has 4 individual bonding electrons. Carbon will always want to make 4 bonds, and that's one of the questions from the assignment today, is that carbon is always going to want to make 4 bonds. All right, so let's start bonding away. If I do this and make this sigma bond here, and I make this sigma bond here, it does not satisfy the octet of anybody. And the whole point of this bonding is to satisfy the octet. So I'm going to have to make a second set of bonds here. And these pi bonds that I make, this will be a pi bond here, and this one here. This now satisfies the octet of everything, and this is going to create my carbon dioxide. Now, what I'm going to do here is just draw this a second time. Carbon in the middle, double bonded on either side, like this. And I'm just going to put those dots there like that. And that's how that structure would look. Oxygen here is usually double bonded to itself with its electrons like that. Okay? All right. Now, I'm not trying to imply that double bonding is tremendously common here, but I need to show it to you. Okay, this is how it looks when you form it. In the center is the sigma bond, here the single or sigma bond in the center. Pi bonds are around the center, and that much like the bun on a hot dog. And yeah, I've actually bought in hot dogs and buns to demonstrate this for you. It has to be a class where people don't mind hot dogs. Okay, triple bonds. This is as far as you go. There's no quadruple bonds, but you can make a triple bond. If you're asking that for yourself, you can. It's when two nonmetals share three pairs of electrons. And the first example I'm going to show you is N2. Did you know that like almost 80% of the atmosphere around you right now is nitrogen, this inert diatomic nitrogen? So I'm going to draw two nitrogens here. And it's kind of cool that it's blue because usually you use blue on nitrogen. So each one has 5 valence electrons. Why 5? Look where it is on the periodic table. Go ahead. I'll wait. All right, now each one has 5 valence electrons. We bonded together like this, and this first bond isn't enough. Each nitrogen now has 1, 2, 3, 4, 5, 6 electrons. This is not enough. So now we make a second bond. Now each electron either has or shares 2, 4, 6, 7 electrons. 7 electrons is still not an octet, so we make a third bond. So why is in order to form an octet. That is the why of it. It has to be to form an octet. So nitrogen exists as a triple bond like that. And that's what makes nitrogen so inert in the environment. Um, if the car tires that on the tires on the car that you drive, if they have little green caps on them, usually that means they got filled up with nitrogen, and it's used because it's a very dry gas. So there's only two elements that I'm going to let you make triple bonds with because the only two it really comes through. One is nitrogen, and the second one is carbon. And here is C2H2. So let's make some C2H2 here. And what we're going to do is do this, and we'll start again. And C2H2, here's a carbon with 4 valence electrons. Here's another carbon with 4 valence electrons. Always kind of go or try for symmetricality in your structures. So I'm going to put a hydrogen on this end, and I'll put another hydrogen on this end, and I'll bond this thing together and start making a chain out of it like this. Now, each hydrogen is stable because hydrogen only needs 2 electrons to be stable. It has its full duet. However, each carbon only has 6 electrons. So we're going to have to make a second bond and a third bond. This will now give each carbon 8 electrons. If we draw this, we get to this, and each bond means 2 electrons, and there's 4 bonds around each carbon, which means they have an octet. Why have we done this? We have done this to make an octet. By the way, the top bottom and the bottom here, bottom bond here were pi bonds. Okay. Uh, this is just again showing you the single pi bond. Pi bonds are split apart like that, but I just usually use this slide for it. Now, drawing Lewis dot structures. There's 6 rules. I'm going to race through them here. I put them in your assignment. You're going to want to run them off and have them next to you, and they will become pretty automatic. First, determine which atoms are bonded to which. Always start with your lowest electronegativity and most bonding atom in the center. In general, unless it's water, we never put oxygen in the middle. Number 2, total up the valence electrons. Add or subtract electrons if there is a charge. So if there's a charge and it's a positive charge, you take an electron away. If it's a negative charge, you add one. Put 2 electrons in any bond. Number 4, complete the octets of atoms attached to the central atom, except hydrogen, because hydrogen only needs the 2 electrons. Number 5, place any remaining electrons on the central atom in pairs. This will be unusual for us, but we might get there. I don't think we're going to get there. And then I think there's a rule number 6 here. Oh, I'm kind of stuck. Okay. Number 6, if needed, form multiple bonds to satisfy the octet of the central atom. So being that we're doing this at home, rule 5, not going to come into play too much, but rule 6 definitely will. All right, here's the 2 examples that I'm going to show you. I'm going to show you how I want you to do them, and then I'm going to give you 6 to practice. Now, water. Each hydrogen has one valence electron. So that's 2, plus oxygen has 6, means I have to have 8 electrons in my final structure. Oxygen is going to go in the middle because it has the most bonding electrons. Hydrogen cannot be in the middle, it just can't. It only makes one bond. And then I'm going to put a hydrogen here and a hydrogen here. I'm going to bond them like this. This works. Why does this work? Because everybody has an octet and the 2 hydrogens have a duet. So this worked. I didn't need a multiple bond or anything like that. Notice that oxygen here has 2 unshared pairs of electrons, which, by the way, I don't think it was clear enough on the last video. There's 2 unshared pairs of electrons. Here, nitrogen has 5 valence electrons plus 1 on each of the hydrogens. Gets me to 8 electrons. I'm going to put nitrogen in the middle. It has the most bonding electrons. What in the heck is a bonding electron? A single electron is a bonding electron. A single electron is a bonding electron. So each of these hydrogens has a single electron, which means it's a bonding electron. Nitrogen has 5, but 2 of them up here that are paired up already will never be used in bonding, not usual bonding anyway. So now I'm going to make my structure and bond it all together. Here we go. That's 1, that's 2, and that's 3, like that. Okay, each hydrogen is done because it has 2 electrons to it. Nitrogen is done because it has 8 electrons around it. And now we understand that a single electron is a bonding electron. So, like carbon has 4 bonding electrons. Nitrogen, like this, has a pair and then 3 that are single. It has 3 bonding electrons. And oxygen, which has 6 electrons like this, has 2 bonding electrons. And then chlorine and the other halogens, which have 7 valence electrons, only have 1 bonding electron. And they only make 1 bond to make an octet. Okay, I'm going to let you loose on some practice here. This is not a one-day skill. This is a multiple-day skills. We'll be working on it at least Friday, and then we have a long weekend. And next week, this will be our sort of our final big topic that we do, and we'll add a lot of detail to it. I hope you're fine. I hope you're well, and you've been running around the yard at times and getting some sun. And that I hope you're doing well in your APs. And I'll be quiet. Take care. Bye bye.